At Caliper, we know way too much about radars. Now, that doesn't make for the most interesting barbecue conversation, but I thought I'd take the time today to answer some of your most frequently asked questions. Okay, let's get stuck in. What are the different types of radars? Okay, so there's pulse radar, there's continuous wave radar, there's Doppler, there's phased array, and they're all suited to a range of different applications. Specifically in IoT though, where we've got a low power consumption at the top of our priority list, pulse radar is ideal for that because you send out a bunch of pulses, and then you go to sleep, and then you send out a bunch of pulses, and you go back to sleep, and you take infrequent measurements to build an image of your total water profile, grain profile, whatever it might be, while consuming the least amount of battery possible. Okay, those were totally normal noises. Let's move on to the next one. So, can it get wet? Well, yes and no, depending on the radar for the application. Certainly ours, where they've been designed to be deployed in wet environments like wastewater networks, have absolutely been designed to withstand wet conditions. Up to IP68 being submerged for 5 meters over 14 days, but other radars are used in medical applications in a lab and absolutely can't get wet or even dusty. So it's just about choosing the right radar for the right job. Alrighty. So, what are the future trends of radar in IoT? Good question. I mean, like any technology, it's going to keep getting smaller, cheaper, more accessible, and we're going to see it used in more places. I think the real thing and the real trend that's important and of value to everybody is how that data is being used. It's not just for arbitrary measurements where you can create millions of data points and not even look at a single one of those. It's about identifying the critical data points and alerting your operations teams to where things might be an issue and using that data effectively. Okay, next one. Let's have a look. How secure are radars? Well, it's not actually the radars themselves that are inherently insecure. It's the whole back end behind it. It's the mechanism of transporting the data from the radar to where you need it. So things like encryption at the device layer and on the cloud can support to ensure that the radar itself doesn't become a vulnerability in your network. All right, moving on. Ooh, what are the limitations of radars? Well, I mean, there's a few things, right? There's the environmental limitations of gaseous or dusty environments potentially having too much particulate in the air and the radar can't see through it. The limitations of the hardware itself being the range that it can measure to or the frequency at which it can measure. But once you've ticked all of those boxes, I think the real biggest limitation is the install itself. If you don't get the installation right, it can actually stuff up your data, so much so that it's inconsistent or even completely unusable. So I think nailing those installs and having the right hardware and training in place for those day one installs is gonna spell success for the rest of the install and for years to come, having that reliable data. Okay, next one. What frequencies do radars operate at? Oh, again, it's such a spectrum of frequencies and why you would use a particular frequency over another one and different applications. But I mean, we're using 60 gigahertz because if we were using 10 gigahertz like you would in defense on a big radar dish, you couldn't install that in a sewer or these tight, hard to reach places that we're able to install our device in. So really choosing that frequency allows us to have a really small package, but that tight beam angle to ensure we're getting really accurate data. Now, it's been a week or so since we first started filming this video, and we've had a couple more questions come in, so we thought we'd answer those as well. What are the main applications of radar? So radar's been around for decades and used across a range of applications like defense, space travel, even medical industries. But where we predominantly use radar in IoT is for level monitoring. Now, in the wastewater network, we've used it to monitor critical water levels to prevent overflows. In agriculture, it's for measuring things like bulk storage of chemicals or grain for animals. And in oil and gas, it's to monitor those critical quantities or even the waste storage facility. What those all have in common is that those critical level alarms are going to provide business efficiencies, saving time and money. Okay, last question. How do radars fail? Well, if we consider that a radar is installed correctly and it's operating within its normal conditions, it's not really the radar itself that's failing, but the data that's being generated. Now, failing or bad data can be generated when there's obstructions in the way. So if we look at a wastewater application where we're in a manhole looking down at a channel, there could be things like ladders or pipes in the way, which are providing false positives back to the radar. That's a fail. If we're in a large grain silo, we could actually be getting multipath up the inside of the walls. That's a fail. And in something like a chemical or bulk storage scenario where you've got baffles in your storage container itself, those baffles might be providing false readings back. That's a fail as well. I think what's important is that the radar itself has smarts built into it to filter out all that mess and only send back good data. So if you have any questions about how we solve that on our radar or Spectra, you can head to our website to find out more.